Thank you very much for attending this presentation. I will talk about 5G security. You will actually, what I wanted is to present, what we do generally for operators, or even private operators who run 5G today, including, for example, insurances, even banks, etc., who actually adopt now 5G today, but not only those one, but also operators. And also, I wanted to demysticate these things because, a lot of people are thinking that 5G can be very complicated. So my job today is probably just to show you that that is not, a very complicated topic. It's just a topic that, of course, requires like a lot of knowledge. But once you are, driving in the good way, good path, normally you should actually have fun. Before we do that, I will probably just introduce myself, but just very, very quickly because I think that you will be probably bored. So I'm Dudek Sébastien. As you can probably hear, I'm also French, so that's why also I have like a very strange accent sometimes. I'm a CEO of Penthertz, which is a company which is specialized, focusing only on radio hardware security. And what we do also in hardwear.io, we do trainings about SDRs most of the time. So if you're interested also to join this kind of trainings, we will be happy to also welcome you. So because I don't like also to feel old. I have a little bit more than 10 years of experience in software and hardware security. I have actually a mix of different experience, like as a security researcher, pen tester, red teamer, and vulnerability researcher. So, all this experience I have mixed in order to make my own company. We do also some activities like security assessment, trainings, etc. I don't want to bore you about these things. Let's go forward about 5G security. 5G, mobile modules are generally used everywhere. Like you can find them even in cars today. For example, you can control your car with an application today. And what is interesting is that even though, those cars are not using, all these cars are not using 5G, they will use it after. And what it is generally interesting is to know exactly how, what kind of angle of attack you can actually find in order to to attack this kind of, cars, for example, or any other objects connected to the mobile stuff. So let's talk about the evolution of mobile. So we first started with 1G, which is the first generation, which was probably the less secure ever. Then there was the 2G. 2G, you know that 2G security also was kind of broken. Because firstly you didn't have like a mutual notification. So 3G, 4G, 5G came after that with mutual notification, which allows to have like some sort of a trust between a mobile phone and a telecom operator. But 2G missed that thing. And so along the radio, all along the evolution of the radio as well as the security came also 5G. 1G, as I said, was like an analog phone. So even though you didn't know anything about SDR stuff or even radio stuff, if you had like a way, for example, to demodulate FM, for example, frequency modulation signal, and you could actually just tune to the right frequency, for example, you could listen to people communications just like that. It was really simple. But things evolved. Now we are not using analog, we are using numeric solutions like 2G to 4G and 5G. In 2G, 4G, you will see also that, the evolution was that way that we had 2G and then 3G came with, the same architecture as before, but providing the IP. So like that, since 3G, you are, even 2G, 2.5G, you're able to communicate to the internet, and with 3G, with much more capabilities and so on. So today, we are most used now to use, for example, our mobile phone for Instagram, more Facebook, and so on, thanks to this evolution, thanks to the way, the gateways that were introduced and so on. So I will not go in details about this architecture because it will take too much time. Now since 5G, we have also two type of architecture. We have 5G NSA. 5G NSA, it is not what you actually think if you are not familiar with it. It just means non-standalone, which is actually a mode that we in France, generally, we use still a lot. we are still waiting for 5G SA, which is the real 5G. But yeah, what 5G NSA is, I mean, the 5G radio, but with the 4G core network. So normally in France and in other countries, but in other countries which are much more evaluated, we can find 5G SA, which is the standalone mode, on which now we have a new NGC, so new generation core network, which normally also is very convenient because as an operator, you can run, for example, your core network in-house, but you can also, ask, I don't know, Amazon or any other cloud in order to, for example, if you need much more capacity, for example, in the case you want to run your core network in case of a big event like, I mean, the Olympics, for example, I mean, that kind of stuff can be very helpful. And what is also interesting also in 5G is that we have also many stuff that change. You have to know that, I mean, before 5G, I mean, there was like a lot of things to know about telecom, like all the protocol and so on. And since 5G, everything has been changed. I mean, people are also, in this field, things that, I mean, by removing all the vulnerability, the all telecom vulnerability, they also removed a lot of vulnerability, which is actually not true. They just replace them with something new. And you will see that now, since we are using, for example, 5G service-based architecture, we are actually introducing new vectors of attack, web vectors of attack instead. We have also the concept of 5G slices. So 5G slices are a way, for example, for an operator, even private operator, to separate, I mean, different contexts. So for example, let's say that you want someone having like a number to be like in a specific network. I mean, you can isolate it, and you can also create some networks, so slices for mobile broadband, C2X automotive, and so on. So it's like a sort of isolation that comes in addition to APN, access point name, that we are used to use today. I was quick about it, but yeah, the evolution is like that. So generally, people, who are used to that know that 5G, I mean 2G is actually very, very broken in many perspectives. 3G, we have some exception related to the use of the SIM card that is in use. 4G, we are starting to have something much more interesting. But yeah, still, I mean, there's some mechanisms that are not enforced, and 5G is the most secure one. So this is what we have in mind. This is actually, if you look at that, I mean, deeply, is some kind of an illusion because everything depends also on your modem and also the operator's enforcement, configuration enforcement. So I will explain about that. So when we test, for example, 5G, configuration, 5G setup, we generally try to test it against some cells, in a specific location, because the operator wants us to test it in a specific location, and we will try to find what are the type of configuration that are enforced on the cells. So also, what is important to know is, first of all, when we start from the external point of view, it's also difficult to, if you don't know exactly how the 5G network looks like, it's good to maybe have a way to actually map different kind of vectors. So what I generally suggest, for example, when you begin also in 5G is just probably to take a look at some project like, for example, for Open5GS, which actually also describe very well all possible kind of vectors. And that is actually very interesting because then just looking at this little schema, which is really well made and actually also reflect all the standard that we use in telecom today, you can also have a look and you can also have some idea of vectors of attack like that are actually in the RAID. So when you want to test, for example, GNB with a real modem, so this is what we want, for example, to do if you want to know exactly what is enforced on GNB side, so on the radio side, we'll just place, for example, a modem, and we'll try to connect to this modem and try to also interact with this modem by trying to force also the GNB to talk with the configuration we want. So we try to just use a modem. So first we try to, for example, map we'll try to. That is a modem that will that allows us, for example, to have like a JAG interface. And allows us, for example, to see, for example, what happens between the modem and the GNB. But if we want to go deeper, we need also to modify the firmware, or we have also other tools. But I mean, with this modem, you can still, for example, see different type of things. So first, do you use, for example, 5G NSA or SA? What kind of mechanism? I mean, by default, the GNB will actually enforce. But yeah, you're still limited with this kind of modem. So yeah, the possible tests are the following. So you can fingerprint, for example, the cells and test their isolation. You can also fingerprint the user plane integrity, the SUKI configuration, the TOE. I mean, some tests that you can actually do. But if you want to go deeper, we will actually use, for example, a modified modem, or we can also make use of SDR, software-defined radio. And using a software-defined radio, for example, we also have like a little tool called AeroSwift, which allows us, for example, to quickly test, without any issue, with even a Blade Earth, because we have created an image which is capable of running a 5G station, but also a 5G client that we can fully control in order to test the GNBs. So you can also check this project, for example, if you want to do like some tests in 5G as well. And so, yeah, by using the project like SSRun or other project like OpenAir interface, but SSRun is a stack that we like, we'll actually act as a UE, so a user equipment, which will connect to a GNB, and then we'll try to force some connections by trying to register to the GNB. So first, we'll configure it in order to match actually the frequency in use by the cell that we want to test, and then also we provide also the SIM card on the PCC reader, and then we can try to test. And we will try to also force the different possibility, like for example, something that we can enforce on a legitimate domain without modifying the firmware is the way that we can enforce the way that a modem does not support anything else than null cipher or null integrity. So if the cell, for example, supports it, I mean, this is a misconfiguration that actually should be patched, for example. But the GNB are not the only target. Of course, we can do the reverse exactly by acting as a GNB, and we can also test devices. So we can also try to downgrade devices with the same way, but in reverse, by doing like some 5G to 4G, and then 4G to 2G downgrading. So yeah, it is also the dumb jamming attack in order to test the devices. If now we want to do like we want to pen test the network, for example, what we'll do is that we'll try to map, for example, the exposed nodes in order to have at least a foot inside the network. And yeah, of course, testing a core network is not an easy way, because Jenny, if you want to do that externally, you have, two ways exactly. You have the legit way by paying access. It costs like 20,000 euro, and then also a lot of paperwork. So yeah, you can have some SS7 access, diameter, and some other 5G access. Or you can also use non-legitimate access, like for example, looking at showdown exposed node and try to find, for example, let's say, a GPRS tunnel in order to get at least a foot inside the network. But yeah, for this task, what was cool also in the past is that we got like a lot of opportunity, legitimate opportunity, where we could actually test this assumption, like the 5G cyber hack in 2019 and 2021. And the first task that we had is to actually penetrate the network and test the isolation. So to test the isolation, we got, for example, first, a SIM card. This SIM card normally is supposed to be used with a phone to connect to a network that was using 5G at the time. That was like for the 5G cyber hack, which belongs to a university. And so using the SIM card, we could actually just bypass a bit things. We didn't bypass, a lot of things at the end, because we tried to map as much things as possible, as much resources as possible, and we could actually see that the isolation was actually not right, as that we also could, map some critical servers, even some management servers that actually manage, for example, the 5G network. So I will just, hidden the brown that is in use, but with the color, you will probably just have a clue of what kind of product it is. So we also found some some LCA, so some vulnerability that we could also use against the platform, and we also had an access to the IMSI, which actually holds all the secrets of the users. So that was actually fun. because it actually showed that if the network is not well isolated, and then we could actually find, a vulnerability inside a product that is in use, like Nokia, etc., we could actually just dump everything. So this is like also a read about that. So if you're interested about that, don't hesitate to read it. I mean, I will also share the slide later. So yeah, for the people who are curious, this is also, a nice read. The assessment inside the 5G SA network. So when you have a foot inside the SAN network, inside the 5G SA network, then you have a lot of possibilities. Of course, a lot of misconfiguration can happen because, when operators and also private 5G networks maintainers are running a network, sometimes they can also misconfigure things, and with this misconfiguration can happen some dirty stuff. Of course, yeah. Still also, just looking also at the outside, with the second challenge that we got from Finland with the 5G cyber hack, we also try to map, as much IP address, as much range as possible, because they just provided us like a SSH access in order to get a foot inside the core network. But we find another way, because we didn't want to use our legitimate SSH access to have a foot. We wanted to do that, completely like from the outside. And so we mapped all the IP address, and we could actually find some nice exploited servers, as well as a UP, a gateway UPF management console. And bypassing this console, we have been able, for example, to bypass the login, export the IMSI, as well as the KI secrets. So even having the IMSI and KI secrets, we could also just clone, for example, any user. We could impersonate a user, and we could also connect into the network. So another task that we did also, having a foot inside the network, we could actually just test also the service-based architecture function that you can see here. And for that, Jenny, this is not an easy task, because if you don't have any tools, you are lost. At the very beginning, we were like, okay, so some API that we don't know. So how we should actually do something? Because maybe with this API we can actually mess in order to have like some secrets, or we can maybe just hijack the communication. We didn't know anything about that, so we had to read it, and we had to also make some tools. So I have made also some tools in the past, but I have also renewed these tools. Like for example, in 2025, I have released a little tool called 5GC API pentest, which actually allows you, for example, to do some scanning vulnerability, key extraction, API fuzzing, to manage also tests. You could do like a lot of automatic stuff. And also I made this tool in order to, to test the telecom network automatically. So like that, I can just like run the tool and go grab a coffee and also a cookie. So I can maybe show you, how it does work. So I will just like simulate here, the telco network here, like that. So LoRaWAN, I will now go up. Oh, it's not that. Up, sorry. Up, exec, telcom, Mongo, voila, and then I would just like put Burp Suite, and you will see that instead of pen testing some telco dark protocols, I'm testing some web API, which is kind of fun because for some people it's kind of fun. But know that, for example, if you're used to pen test web stuff today, doing 5G stuff will not be so different with the right tools. So now I'm just launching Burp Suite. I will access to my plugin, and I will just like start an audit. So of course, in the configuration, I will need to at least configure the NRF URL, which is in here. But yeah, as I'm using this IP address, which is local, I would just like let it as it is, because I'm just simulating a network. So I'm just imagine that now I have a foot inside the core network. I know where the NRF address is. Only that, I can just do auto audit, and then I can dump the whole thing, so I can for example, try to find the different functions automatically. I can also dump the secrets, the MSI, and so on. And so this is actually, I mean, a nice tool because now I don't have like any work to do once I have a foot inside the core network because everything is getting tested automatically. And so after that, we have a report even, so we can see the discovered assets, the credentials. So you have like the MSI, the KI. So I can now clone this access in order to impersonate, for example, a subscriber. I can also do like some API fuzzing, external, and so on. I can also have like security issues. So for example, if I want to generate a report, maybe I can use maybe like any MCP things in order to maybe generate a report automatically. But yeah, you have like some vulnerability to report already, which is kind of cool. And yeah, you can also find vulnerability in new stacks. I mean, the new stacks, because I mean, for the moment, it's just like vulnerability with configurations. But yeah, in new stacks, you have to know that we can find some nice bugs as well, because as much you have stacks, as much you can also find some interesting bugs. Like, for example, GTP was actually a nice bug that some people actually tried, because normally GTP should actually only be available at a certain level. But for some people actually try to inject GTP layers as a user equipment. So normally it should never work, but actually just by having an encapsulated GTP layer inside a user, I mean a simple IP packet, they could actually crash the UPF, for example. So the UPF was crashed, and so you had also, I mean, the service, the telco service was lost. Also, there was like inside the core network some vulnerability that were found in 2021. I mean, in telecom, you don't find like a lot of vulnerability that are found in the air, but maybe looking deeper on that on different implementation like Open 5G stack and over free 5GC and so on. I mean, there should be like a lot of interesting stuff, but yeah, you need also to invest a lot of time on it. But yeah, know that in stacks we can also find some interesting bugs. So you can have also other problems, even the TDIs, for example, that carries, for example, the UL packets can also be impersonated. So you can try to brute force them and then mess with the communication. So you can also sometimes have the packet of someone else. You have also some other vectors like Open RAN. Open RAN, I don't know if you heard about Open RAN, but this is also part of the change that will happen also in the mobile industry, because instead of having a RAN that will actually run everything, we actually want to segregate everything in a way that we can have different parts running, I mean different kind of feature. So you have to know that before the Open RAN, we used to use, we still use the RAN, which is a little bit inflexible. Also, it's dependent to the vendors. So sometimes if you have, like, for example, let's say a RAN, if you want, for example, to connect the RAN to something else, you need to also have the same vendors. If not, sometimes the connection is not compatible. So it's, it can be like, a lot of money to spend. So Open RAN actually reduces the cost and provides much more interoperability between the different components in telecom industry. And so just like that, if you look at the architecture of Open RAN, it's just like a way to, we can have like a radio, we can have also different function in the same machine, or we can split everything. So a different function can be split over different computers. So yeah, if let's say you need more resource for a certain function, you can also plug them exactly like a virtual server like that. So yeah, and yeah, of course, as we have also different function that can be split, of course, you can also have different exposed interface. So you can have like a NGC, NGU, etc., E2 that will be exposed. What is actually interesting in Open RAN is that normally it's supposed to be run with Kubernetes. So for example, if you are used to do like Kubernetes pen test, you are invited to use these skills against Open RAN. And yeah, generally you will, for example, check the status, you will check the different endpoints, and sometimes you will probably also figure out that the Kubernetes is not well configured in this in some situations. So you're also able to list the pods, and you're able to even execute some code commands in the pods. Something that is also interesting, because yeah, here is when you want to infect a container. So when you are able to execute some code in the container, you can also infect the container, and so then you can pivot, and you can try to pivot into the other networks, even the internal network of the telecom operator. Yeah, you have also the ETZ interface, which could be also interesting to look at. I mean, there's like many things. Something here that also is interesting to look at is the X app. So this is one of the new things that appears generally in the telco industry, especially for the Open RAN, is that Open RAN allows, for example, to extend also some functions. So you can also provide your own function on the Open RAN to, for example, monitor for something or do like any task. And X app, for example, if you have an access to X app through the chart museum of the Open RAN, you are able to also backdoor a chart. I mean, you can, for example, make your own function, your own X app, and making your own X app, for example, you can make it with Python, Rust, Go, C++. I mean, you have the flavor of what kind of backdoor you want to do. I mean, depending on the language you are used to use. So yeah, if you're able to list also, I mean, to access to the chart museum that is exposed, you can actually do like some pretty bad stuff. So for example, here's like a little example of, I mean, a malware that I did like very quickly. And using this little code, I could push this app in the chart museum. And then I was waiting until an admin just triggered it by just doing like some status check or whatever. And then the backdoor was actually running. But yeah, know that also, as I said, as there's like different other interfaces, you can have E2, NFAPI, and so on. I mean, these stacks, I didn't dive into these stacks yet, but I mean, that could be like very interesting also to look at. Other stuff and last stuff, because I mean, yeah, of course, we still have like a lot of stuff to do, but yeah, the telco industry also think about another interesting vector to pen test, which is CAMARA project. And I was actually curious because when I heard about CAMARA, I saw that they want to provide an API which actually gives access to some function of the core network. So that could be like interesting to look at. So looking at it, we see that, I mean, CAMARA is, I mean, a GSMA Open Gateway plus Linux Foundation joint initiative. It gives to the user, to the developer, more than 30 REST API exposing 5G core data. So you can have like the device location, swim swap, QoS, network slicing, subscriber identity, device status, and so on. I mean, many functions, I mean, many API that allows people to have a direct access from the web, from an application to the 5G function, which is actually mind-blowing because this kind of stuff, this kind of access, normally you should have it only inside the core network. But yeah, why not? Because we can do that, right? So yeah, if you want to have access to that, generally you can present yourself as a developer, because I mean, some telecom, for example, like Telefonica and so on, are looking for developers. So you can also ask them for some tokens and some access to that, and you can develop applications around their API. So the operator do not have all the API REST. I mean, some operators support a part of the APIs that are actually standardized, but you can actually find some operators that could be interesting for your case. Know that, as I said, they give you like an API access that, in a developer perspective, at the end, gives you access to, to function that are inside the core network. So, yeah, of course, I mean, these kind of access are pretty fun. And as an example, here's an API that you can use to locate a user. So, for example, if you know someone's number phone, of course, you cannot locate it directly to a special location, but you can try to map it as fast as possible. And mapping it as fast as possible to different locations, you can locate it thereafter. So then different kind of action exists also. I mean, SIM swapping check, number verification, as I said, device status. I mean, all of nice stuff. How we can access to that? As I said, Jenny, for both Telefonica, but also other operator will give you an access, can give you some access, but also you may probably just like find access that could be like maybe exposed by someone that's leaves an exposure. But for the moment, I didn't see that. I mean, it's still in pre-production, so for the moment you will not see it yet. I mean, working, but maybe a few months or a year, that would be like something interesting. Jenny, they do like this kind of, they did this kind of API. Jenny has they want to propose this kind of API for service. So now for some services, for example, for banks, assurance, and also other kind of operator. But we don't know. Maybe publicly also, these services will be also publicly also proposed. We don't know. But for the moment, they think about using these services for assurances and so on. So yeah. But yeah, in a term of, I mean, if you want an access also, I mean, still, as I said, it's still in pre-production, but you can find some, for example, by enumerating some exposed CAMARA endpoints, for example, for Telefonica and so on. You notify the API version. You can also check for authentication, of course. You will need the token, as far as I know, because I mean, you need to be authenticated to use the API, but we never know. Generally, you need to be authenticated for that. So at least a token will be needed. But once you have that, you can access the API and mess with this API. So yeah, the conclusion is that it's just 5G is not inherently secure. I mean, we think it is secure because most of the people say, yeah, we have patched every possible vulnerability, but finally, it does just provide much more services, so much more vectors of attack. As I said, 5G core network now is a little bit less scary than in 3G, 4G, because now it's just like REST API, so with a Burp, with a Burp software, you can also pen test them. And now we have, with our extension, you can also do that pretty easily. Open also expand the attack surface, as I said. So, you have Kubernetes, but also other interface you can play with. So if the people running OpenRun do not isolate it properly, for example, through an IPsec or whatever, I mean, it could be problematic. And same, CAMARA API is bringing something new. I mean, so it will be still interesting. But yeah, you don't think that at the end, I mean, this is over. I mean, all the vulnerabilities are over. Just the vulnerability moved to another playground. So yeah. So thank you very much, and don't hesitate if you have any question. I'm actually available. Also, if you want like some other, let's say, how to say, demos or whatever in radio or even with some core network, I can actually also do that later on the table because I brought also some nice stuff in radio. So yeah, don't hesitate to ask. Thank you very much.